Student, let us start our session 3, chapter number 5, probability. Already many things I told you about the probability. Now today we will be starting a actual thing. Actual thing means purposeful thing. I will be telling you some questions of exercise also. You also start solving the examples, and whenever you have a doubt you can just note it down and you can tell me afterwards. Before going for anything new, let us revise again some of the topics, because revision is necessary. Everything is new for you. So types of event, let us relook again. Types of event, main topics of our types of event, and example, and then we will start exercise 1.1. So come on, first of all, types of event. As I told you, what is the event? Any subset of universal set is called as a event. Under the heading of types of events, any subset of universal set is called event. Already I told you. For example, if you are tossing the coin, then it's an event. If you are throwing the dice, it's an event. So this is called an event. And universal set is actually a sample space, all the possible outcome. Then second one is certain event. An event whose occurring possibility is 100%, which is going to occur 100%. There is no option. Then such type of a event is called certain event. For example, already I have given you an example. If you print 1 in all the part of all the face of a cubite or cube and throw it, you will always get 1. So it is called as a certain event. Then impossible event, the event which is not going to occur at all, event whose possibility is 0, then it is called as a impossible event. Complementary event is that event whose member, whose element does not belongs to a given event. For example, U is a universal set, and in a universal set, if you remove the member of A, then whatever it comes, that is called complementary event. And as already I told you, it is denoted by letter A dash. Then difference of event or difference event, if you are just finding difference in a two event, means member belongs to first event but does not belong to second, then it is called difference of event. Mutually exclusive event, if there are two events which does not have any common element, A intersection B is equal to null set, then mutually exclusive event. Mutually exhaustive event, if you are combining all the events and if it is equal to sample space or universal set, then it is called as a mutually exhaustive event. Everything already I told you twice, I am repeating again. Then today onwards, we will be using this to solve the exercise. So remember the name. Mutually exclusive means no common element. Mutually exhaustive means if you are combining all the events. For example, if there are two events A and B, and if you are combining this A and B and you get a universal set or total sample space, then it is exhaustive. If both the properties are applicable, both the properties means intersection is null set, union is universal set, then it is called mutually exclusive and exhaustive event. There are many questions in our exercise. Gradually we are going to see this also. Then intersection of event. If there are two events, then we are talking about such event which got something common. For example, A intersection B means common in A, common in B, then whatever the answer comes, that comes under the heading of intersection of events. Then union of events means when you combine two or more than two events, then the resultant event is called union. I already gave you symbol. U is the symbol, not capital U. Simple U is the symbol for union. Reverse of U, inverse of U, that is for intersection. Elementary events means fundamental event or event, a basic event actually, or all the subset, individual subset is actually called as elementary event. For example, S is sample space of tossing the coin, HH, then HT then TH, then TT. Then if you deal with the individual event, getting up a two head, getting up a two tails, getting up head or tail, or getting up tail and head, if you are dealing with the individual elements, then it is called elementary events. Everything already I told you in second session, but repeating because revision is required. Now we are going to apply this in a exercise. So there is one easy exercise. Already some of the questions you did in a 10th standard also. Probability chapter was there in the 10th standard. There you already studied how to make a sample space. But then again, some easy question in this session I am going to tell you. Some typical one in a coming session. So exercise 1.1 on page number 14. 14 and 15 are the page. But today, page number 14, some easy questions I am going to tell you. So there is one question, question number 1, and question number 1 got 3 parts. In all the 3 parts, they are asking you to make the sample space. I have selected first part. What is that first part? Obtain the sample space when coin is thrown thrice. If you are throwing the coin thrice, then how many outcomes you are going to get? First of all, let us see outcome. All the 3 heads, head and head, tail, then head, tail, head, or tail, head, head. These are the outcomes where head is involved. Then 2 tails, tail, 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 head, tail, or S, tail, tail, or otherwise all the 3 tails. So there are total number of 8 outcomes. Now onwards, when they are asking you to write the sample space, then together with sample space, we'll start writing the total number of element of that sample space, because it is required in solving the question. We are not going to use a complete letter for writing that event. You can use a small letter. For example, head will be denoted by capital H, tail will be denoted by tail. No need of telling, because in a book they took it as obvious. So H stands for head, T for tail. So when you throw that dice 3 times, you are going to get 8 elements. Suppose same example, sample space when dice is thrown 4 times. So how many events we are going to get? If a dice is thrown 4 times, then there are going to be 16 elements. 2 into 2 into 2 into 2. Why 2? There are 2 options, head and tail, and there are going to be 16 total member of event. What type of events? Suppose if anybody is asking you to make a sample space of 4 times throwing the coin. So what are the elements? H, H, H 4 times, tail, tail, tail 4 times, means tail, tail, tail 4 times. Then head and tail is going to randomly distributed. So you are going to get the 16 elements. So in first exercise, still we are waiting for a definition of probability. As I told you, after exercise 1.1, you are going to get the definition of a probability. So in first exercise, they are telling you how to make a sample space. If you know how to make the sample space, then 50% of chapter is over. So I am not going to be in hurry. We'll be trying the maximum question to be solved. I will be solving, some of you solve. There are many examples with the figure also. As I told you during the types of events, Venn diagram plays a very important role. So slowly we are going to use our Venn diagram also to denote that event. As it comes, I am going to tell you. Then question number 2 is easy one. I went for question number 3. In question number 3, question is sample space for selecting one minister and one deputy minister. Just see the question in your book. Sample space of making one minister and one deputy minister out of 4 persons. Now if there are 4 persons, remember in 11th class we were using combination. So out of 4 persons, 1 person can be minister, and it can be selected, remember. It can be selected in 4C1 ways. Now we are using combination of 11th class. Now after selecting the 1 person for a minister, then remaining person is 3, and out of this 3, again one of the person will be selected for a deputy minister. So total member will be 4C1 into 3C1, it is equal to 12. 4 3s are 12 members. See, we are using a 11th standard combination topic. but somebody is asking you, suppose to make a sample space, because I told you exercise 1.1, how to make the sample space. Letter can be different in this your backside answer. Purposefully I took a letter P1, P2. P1 and P2 are the person. First person is denoted by P1, second person is denoted by P2. Then there are 4 persons, third person is denoted by P3 and fourth person is denoted by 4. If you want to write the name of that 4 person, it's up to you. Then you will have to write the name again and again. Now we want to select 2 members. Very important question, question number 3 is, you want to make a 2 person, first should be minister and second should be deputy minister. There is no question of a repetition. One person cannot have a 2 posts. So there is no chance of getting this type of P1, P1 or P2, P2, because 2 persons are going to be different. So what are the different types of this post? See, person 1, person 2. One of the arrangement is P1, P2, P2, P1, P1, P3, P3, P1. In a backside, answer is given in the form of A, B, C, D. Small a, small b, small c, small d. Letter is your choice, but whichever the letter you are going to use, you just mention it. For example, here I wrote 4 person P1, P2, P3, P4. In a textbook, they are writing A, B, C, D. It's your choice. Again, I am telling you. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 different types of arrangement you are going to get. Just you arrange the or rearrange the members, you are going to get the 12 options as you are finding on a board. P1, P2, P2, P1. Immediately you reverse it. P1, P3, P3, P1. Another. It means the third person will be minister, then first person will be deputy minister. First person will be minister, then fourth person will be deputy minister. Fourth person will be deputy minister, then first one will be deputy minister. In that way, you are going to get the 12 arrangement as we did in the combination in 11th class. So this is question number 3, slightly more important than question number 1. Then one more nice question is, and question number 7 will be repeated again in a coming exercise also. Again, you try 4th one, 5th one, they are easy question. Now question number 7 is, a family is selected having 2 child. Any general family having 2 child. Now when we are talking about child, then we don't know whether they are boys or girls. So 2 childs, it can be both the boys, B stands for boys. It can be both the boys. It can be the elder one boy, the younger one girl, or elder one girl, younger one boy, or both the girls. So total number, again I am telling you, you should know the total number of outcome, because that we are going to use in a coming exercise. So total number of outcome is 4. And what are the 4? BB means boy and boy, BG boy and girl, GB girl and boy, GG both the girls. This way we will get a total outcome. In this question number 7, they have mentioned 2 more part of that question. They are asking you to find the event A1 when child is only female. So the child is only female, both the child is female. So what are the options? BG means boy and girl, or GB girl and boy. When one child is female, remember, not both child, one child is female. So either boy and girl or girl and boy. This is one of the part of question number 7. Second part of the question is, that is more important, and second part is it is denoted by letter A2, that event. They say at least one child is female. At least means minimum one child is female. So say BG, one child is female, GB, one child is female, GG means at least one. So 2 child can also be female. In that way we get the answer of A2. So question number 1, 3, 7 I solved in this session, and you solve some of the example. Some other question I am going to tell you in a second session. I want to introduce a new topic also, in which we can utilize this data for solving the question. So I am not skipping this exercise. You solve example, you solve some of the questions of this exercise. Some of the questions are directly from the 10th standard, and examples are new to you. You solve that example, The difficulties I will be saying you afterwards. Today, the new topic I am going to tell you, so that you will come to know the definition of probability. I am also eager to tell you the definition of probability. Already we started this probability, we spent a 2 session. So in this 3rd session, I want to tell you the definition. Now after doing some question of exercise 1.1, now I want to introduce the definition of probability. For introducing the definition of probability also, we required one more type of event. Already 10 to 11 types of event we saw. One last type of event is equiprobable event. You just see the name equiprobable, means those event whose probability is equal. Probability of occurring is equal. It is called equiprobable event. Equal, probable means probability. So those events whose probability is equal are called equiprobable event. One of the example is throwing up a dice. Throwing up a dice, see, there are 6 outcomes. 1, 2, 3, 4, 5, 6. There are 6 outcomes. Now if I say probability of getting 1, before probability of getting 1, you see 1 member, 2 member, 3, 4, 5, 6. All the 6 events got equal chance of occurring. If you throw the dice, it can be 1 also, it can be 2 also, it can be 3, it can be 4, it can be 5, it can be 6. If the occurring chance, probability I will be telling you in the next topic, if occurring chance is equal, then we say equiprobable event. Using this concept, we got the definition of probability. We were waiting for the definition of probability. So definition of probability is as it is given in your book. Probability of any event. Probability of any event. Suppose that event is A. The letters used in our book is M by N. Different books use the different letters. Here in our textbook, they are using the letters M by N. Now, what is M? M is a number of favorable event and N is total number of event. Now, what do you mean by favorable event? Favorable event means those events which you want to deal with, whose probability you want to find. For example, if I throw the dice once, if I say that I want to get the even prime number, my favorable event is even prime number. You see, there is only one event which is even as well as prime number. If I want to find the probability of this event, so according to this formula, M will be only one member, that is 2, and total number of outcome is 6. Total number of outcome, it can be 1 also, it can be 2, 3, 4, 5, 6. So now the definition of probability is, probability's definition is probability of A is equal to 1 by 6. Similarly, if anybody is asking me to get the event of multiple of 5, so there is only one event 5 which is multiple of 5. So its probability will be again 1 by 6. This definition first of all was given by Carl Pearson. We heard about the Carl Pearson in 11th class. In a 10th standard also this definition is given to us. Carl Pearson gave this formula, and formula which we are going to use in second exercise. This formula is called empirical formula. What do you mean by empirical formula? If you are deriving any formula by doing experiment again and again, then it is called empirical formula. Carl Pearson came across this formula after doing many experiments. 1,000 times he had thrown the coins, 1,000 times he had thrown the dice, and by getting the outcome, he came to know about this formula. So once more, what is that formula? Formula for getting the probability is, now it's the first definition of probability. One more definition you are going to get afterwards. So what is the definition of probability? Probability is defined, probability of any event is defined as number of favorable event. Number of favorable event is event whom we are going to deal with, whose probability you are going to find. So number of favorable event divided by total number of events means total number of outcome. Total number of outcome means total members of a sample space. One more example is on the board. One example already I told you. So one more example is probability of getting even number when dice is thrown once. So dice is thrown once. So total number of outcomes are 1, 2, 3, 4, 5, 6. I told you in the exercise 1.1 also. Now you make a habit of writing total number of members. So total number of members are 6. Now how many numbers are even number? 2, 4, 6. Means m is equal to 3. Divide this 2. You are going to get the probability of getting even number. Now again come back to the equiprobable events. This formula holds for equiprobable events. In your book they have introduced this definition first. Equiprobable event means those events whose probability is same. For example, getting up a 1, getting up a 2, getting up 3, getting up 4, getting up 5, getting up 6. When you throw the dice, its probability is always 1 by 6, 1 by 6. Why 1 by 6? Event is 1 and total number of outcome is 6. So if anybody is asking you, what is the probability of getting 1? 1 by 6. What is the probability of getting 3? 1 by 6. So such type of event is called equiprobable event. One more example is throwing of coin. Throwing of coin, how many outcomes are there? There are 2 outcomes. Suppose A is that event and outcomes are head and tail. So if anybody is asking me, what is the probability of getting head? So 1 by 2. Why 1 by 2? There are 2 outcomes, 2 total number of outcomes. Means n is equal to 2. And getting of head means only 1 head. So answer will be 1 by 2. So the formula which I told you for probability or definition of defining the probability, we are going to use this formula, and there we will be using the concept of equiprobable event. In a numerator, favorable outcome plus these favorable outcomes will have an equal chance of occurring, then we are going to use this. And remember, this formula was given by Carl Pearson after doing a lot of experiments. So now what we are going to do in a coming session, we are going to solve some more question of 1.1, and we will be using this formula to solve 1.2 also. So that we are going to do in our next session.